Hello guys and welcome to
Kaliko TV.
Ang ating pag-uusapan ngayon ay tungkol sa capacitor in series and parallel circuit. Several capacitors may be connected together in a variety of applications. Multiple connections of capacitors act like a single equivalent capacitor. The total capacitance of this equivalent single capacitor depends both on the individual capacitors and how they are connected. There are two simple and common types of connections, called series and parallel, for which we can easily calculate the total capacitance. Certain more complicated connections can also be related to combinations of series and parallel. Ating pag-usapan ngayon ang capacitance that is connected in series. So figure 1 shows a series connection of 3 capacitors with a voltage applied. As for any capacitor, the capacitance of the combination is related to charge and voltage by C equals Q divided by V. So we can find an expression for the total capacitance by considering the voltage across the individual capacitors shown in figure 1. Solving C equals Q divided by V, for V gives voltage equals Q divided by C. The voltage across the individual capacitors are thus V sub 1 equals Q divided by C1. For V sub 2 naman is equal to Q divided by C2, and for V sub 3 equals Q divided by C3. The total voltage is the sum of the individual voltages. So V equals V sub 1 plus V sub 2 plus V sub 3. Now, calling the total capacitance CS for series capacitance, consider that V equals Q divided by CS, which is also equivalent to V sub 1 plus V sub 2 plus V sub 3. So, entering the expressions for V sub 1, V sub 2, and V sub 3, we get Q over CS, or capacitance in series, is equal to Q divided by C1 plus Q divided by C2 plus Q divided by C3. Cancelling the Q's, we obtain the equation for the total capacitance in series, CS to be 1 over CS is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Where 3 dots indicates that the expressions is valid for any number of capacitors connected in series. An expression of this form always results in a total capacitance CS that is less than any of the individual capacitances C1, C2, etc. As example in number 1 illustrates. Kaya magka-come up tayo sa formula in finding the total capacitance in series or CS as follows. 1 over CS is equal to 1 over C1 plus 1 over C2 plus 1 over C3 and so on. What is the series capacitance? So find the total capacitance for 3 capacitors connected in series, given their individual capacitance are 1 microfarad, 5 microfarad, and the third one is 8 microfarad. Solution. Entering the given capacitance into the expressions for 1 over Cs is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So, substitute lang natin yung value. Ang C1 is 1 microfarad, ang C2 is 5 microfarad, and ang C3 is 8 microfarad. So, i-divide lang natin siya. So, magka-come up tayo sa 1.325 microfarad. So, kukunin natin ang reciprocal ng CS. So, inverting to find the CS yields, 1 over CS. So, magka-cross multiplication tayo, then divide both sides. So, CS is equal to the 1 over 1.325. And the final answer is 0.755 microfarad. So from the solution, let's have a short discussion. So the total series capacitance CS is less than the smallest individual capacitance as promised. Second, in series connections of capacitors, the sum is less than the parts. Third, in fact, it is less than any individual. And fourth, note that it is sometimes possible and more convenient to solve an equation like the above by finding the least common denominator, which in this case, showing only whole number calculations, is 40. Thus, 1 over CS is equal to 40 divided by 40 microfarad plus 8 divided by 40 microfarad plus 5 divided by 40 microfarad. So, this will give us 53 over 40 microfarad. So that CS is 40 microfarad divided by 53, or the reciprocal. And the final answer for this one is 0.755 microfarad. Okay, capacitors in parallel is more easier to find than in the series case. So in this figure, this shows a parallel connection of 3 capacitors with a voltage applied. To find the equivalent total capacitance, CP, we first note that the voltage across each capacitor is V, the same as that of the source, since they are connected directly to it through a conductor. Conductors are equipotentials, and so the voltage across the capacitors is the same as that across the voltage source. Thus, the capacitors have the same charges on them as they would have if connected individually to the voltage source.
One day we'll settle away, bell sounds to kiss a girl.
The total charge Q is the sum of the individual charges. Q equals Q1 plus Q2 plus Q3. Parallel capacitance times voltage equals C1 times V plus C2 times V plus C3 times V. Cancelling V from the equation, we obtain the equation for the total capacitance in parallel. Cp equals C1 plus C2 plus C3. Total capacitance in parallel is simply the sum of the individual capacitances. Again, the three dots indicates that expression is valid for any number of capacitors connected in parallel. So, for example, if the capacitors in example 1 were connected in parallel, their capacitance would be for parallel capacitance, which has 1 microfarad plus 5 microfarad plus 8 microfarad gives us 14 microfarad. The equivalent capacitor for a parallel connection has an effectively larger plate area and thus a larger capacitance as illustrated in figure 2b. So the total capacitance in parallel is parallel capacitance is equal to C1 plus C2 plus C3.
Ang susunod na pag-uusapan natin ay kung paano i-test ang capacitor at para malaman kung maayos pa ba ito. At ano ang mga dapat isalang-alang sa pagdi-discharge ng capacitor at gaano to ka-importante or kahalaga na gawin.